Okay, so we've established that our flying car will need some force to hold it up. Now what could that force be? Well, one possibility is buoyancy. You know, buoyancy in hot air balloons and blimps. The idea is if you fill an object with hot air or helium or something like that, it gives it a buoyant force that helps it to fly. So, is it feasible that buoyancy could help keep our flying car up? Maybe if we filled the car up with helium or something like that, or suspended it from a balloon? Well, to work this out, we're going to have to come up with a theory of buoyancy, and that's what this video is about. So the first thing to ask is, where does buoyancy actually come from? Where is this force coming from? What causes a buoyant force on something like a balloon? Well, the way to think about it is to take a slab of air. So, for example, let's take this bit of air in the room here. Now, let's say we've got a cubic meter of air. A cubic meter of air weighs about 1 kilogram. So it weighs about the same as this drink bottle. And if I let go of the drink bottle, it falls. But if I let go of this slab of air, it just stays there. So why doesn't the air in the room all fall until it's a layer on the ground under our feet? Well, let's take a cubic meter of air sitting in the middle of your room. It weighs something. If it's a cubic meter, it weighs 1.2 kilograms, so it's got a force of about 10 newtons downwards. So there has to be some upward force, net upward force, to balance this. Now, what forces are acting on this? Well, basically, it's a pressure force. There's going to be a pressure at the bottom, a pressure pushing down at the top, pressure pushing in at the sides, and so on. Now, you'd think this pressure force would balance out. But if it balances out, the slab of air is going to fall. So in fact, the pressure force mustn't balance out. In fact, the pressure at the bottom, P bottom, must be a little bit more than the pressure at the top. And that slight difference in pressure is what keeps the air up. So that's actually the general physics about why air doesn't fall down. There is a pressure gradient that balances gravity. We'll come back to this in Physics 1201 quite a lot. So for any shape like this, it stays up because the pressure is bigger at the bottom than the top. So in the atmosphere as a whole, pressure is large down there and pressure is small up the top. But how does this help us with buoyancy? Let's say we wanted to work out the buoyant force on a shape like this one, a very strange looking shape. So we'll know the pressure is bigger here than it is at the top. So the pressure force on my bum is going to be a little bit more than the pressure force per unit area on my bald spot. But how do you actually calculate this? If you were dealing with something like a cube, it might be fairly straightforward. You could just calculate the pressure as a function of height and sum it over the top and the bottom. The sides would all cancel out. But for a shape like this, I defy anyone to write down an equation for that sort of shape. However, there is a very, very sneaky trick that allows us to work out extremely easily what the pressure force is, the buoyancy force, which is a net pressure difference, the fact the pressure is more on the bottom than the top, on even the most complicated structures. Now here's how we do it. So here we've got a complicated shape immersed in a fluid. Our trick is to replace that shape with an identical shaped bit of the fluid. So get rid of me and replace me with a pool and fluid-shaped slab of air. Now in this case, we know that this volume of the fluid is not going to move up or down. It's going to sit there. Therefore, the net buoyancy force, net pressure force upwards on that shape must balance the gravity of that shape downwards. The laws of physics work for whatever system you choose, so if you want to choose this rather bizarre shape of fluid as a system, you are perfectly at liberty to do so. So that's the answer. What is the buoyant force on something? If you immerse an object in a fluid, the net buoyancy force on it will be equal and opposite to the weight of the fluid it displaces. So if you want to work out the buoyancy force of any object, what you do is you take that object, get rid of it, and fill the space it used to occupy with whatever the fluid is. Whatever the weight of that fluid is, that is equal opposite to that is the buoyancy force. Now that's a very alien way of thinking, but it's the trick we need to work out buoyancy forces.